Hello everyone, myself Mrs. E. Aksha Prasilda Reena, Assistant Professor, Department of Information Technology, Kongunadu College of Engineering and Technology. So I'm handling principles of operating system for my second year students. So I'm here to take some topics on POS for you guys. Okay. Today we'll be covering the introduction to operating system, one of the most fundamental topics in the computer science. So let's begin with the definition. An operating system, often abbreviated as OS, it is a type of system software. Its main role is to manage the computer hardware and software resources, and also helps to provide services for the computer programs. Think of the operating system as the backbone of any computer system. It ensures that everything runs smoothly by coordinating between different hardware components like the CPU, memory, and storage, and the software applications that we use every day. Uh, some key points we shall discuss. So, the OS acts as a bridge between the user and the hardware. This is a very important point. As users, we don't directly interact with the hardware like processors, memory, or input-output devices. Instead, we interact with the applications, and those applications talk to the operating system, which in turn communicates with the hardware. So the OS plays a middleman role. It ensures that the communication between hardware and software is efficient, secure, and reliable. So for security and efficiency purpose, we are using OS. And another essential responsibility of OS is to allow efficient and secure use of the computer system. It manages multiple tasks, prioritizes them, protects system resources, and ensures that unauthorized users or programs cannot access sensitive information. Um, in short, we can say what is OS. So OS is a system software. It manages both the hardware and software resources, and it provides services for computer programs, and it acts as a bridge between the user and the hardware, and it ensures efficient and secure system operations. That's all. That's all for the for this introduction. Let us see how the operating system functions and manages different situations during the operation of a computer. Okay, so the first important concept is interrupt, which is driven by hardware. When a hardware device like keyboard, mouse, or printer needs the CPU's attention, it sends an interrupt. So the operating system passes the current process, handles the interrupt, and then resumes the process. Next step is we have two exceptions. We have some exceptions or traps which occur due to software errors or special system service requests. For example, if a program tries to divide a number by 0, this causes an exception. In other cases, software may make a system call to request services from the operating system like accessing a file or allocating memory. So let's see some handling process problems here. So there can be many issues while processes run. For example, a program might enter an infinite loop, or some process may try to modify the operating system or interfere with each other. So to prevent these problems, OS ensures that process are isolated and monitored very carefully. So we have two types of operations here. So in dual mode, we have user mode and kernel mode. So to protect the system from such issues, OS uses a concept called dual mode operation. So this means the system operates in two different modes. One is dual mode and one is user mode and another one is kernel mode. So in user mode, where applications and user level programs will run. So in kernel mode, core parts of the operating system will run. So the hardware helps by ensuring that certain instructions can only be executed in kernel mode, protecting the system from malicious or accidental damage. So switching mode is also be there. So when a call system is made, like opening a file or allocating memory, the mode switches from user mode to kernel mode. Once the task is done, the system returns from the call and switches back to user mode, giving control back to the user application. This mode switching mechanism is very crucial for security and stability. Okay, so in short, we can say what is interrupt? Interrupts are triggered by hardware to get CPU attention. Exceptions or trap are caused by software errors or system service requests. Next comes infinite loops and unauthorized access will solve this problem. So dual mode operation provides system security using user mode as well as kernel mode. Mode switching ensures the OS remains in control while allowing user process to function efficiently. Diagram, it is all about dual mode operation. So the system uses a mode bit to indicate the current mode. So mode bit equal to 1 in the user mode, then mode bit will be 0 in kernel mode. So let's walk through the process using the flowchart shown in this slide. So user process execution is the first thing we have to note down. So the system starts in user mode and normal application is running. For example, a text editor or a web browser. So a system call will be made. At some point, the user process need to request a service from the operating system like accessing a file or memory. This will be done using a system call. Okay, if trap is triggered, if a trap is if trap occurs, this is a software triggered interrupt that tells the OS to take control. So the mode bit is set to 0, switching the system into kernel mode. uh, and also we have to uh, focus on the kernel that will execute the system call. So now in kernel mode, the operating system safely executes the system call. It has full access to hardware and also can perform the requested operation. Then comes return from system call. Once the task is completed, the system returns from the system call. Next comes mode bit set to 1 as seen in the slide. So the mode bit is set back to 1, switching back to user mode, and the user process will continue. So we have to uh, think of the importance. So this mechanism ensures user processes are isolated from the core system functions, and also this is very malicious or a very buggy code cannot directly affect the hardware or sensitive parts of the system. So the OS remains in control of critical operations, providing a secure and stable environment. Started with the definition of an OS, understanding it as the essential system software that acts as a bridge between the user and software. Then we have explored about OS operations, including how it handles interrupts, exceptions, and process errors, and ensures system security and efficiency. So finally, we have learned about the concept of dual mode operations, where the OS switches between user mode as well as kernel mode using a mode bit to protect system resources and maintain control. These are some foundational, very basic concept and very crucial for understanding how OS function internally and how they keep our computer stable and secure. Thank you for listening. Let's see you in the next session. Thank you for watching.